All right, now we're going to talk about radioactive decay. What happens when a nucleus of an atom breaks apart? And there are three major particles that are produced when radioactive decay happens: an alpha, and a beta, and a gamma particle. All right, so an alpha is the biggest of the three. Here's the alpha symbol. It looks like that. It's kind of like an A with a tail or a fish or something like that. And it's referred to as a 4-2. All right, so what does that mean? What does that 4-2 mean? Well, if we go back to our atomic symbols, and if we put a number up here, we refer to that as the mass of the atom. So like a carbon 12 or a magnesium 25. It's the mass of that atom. And this one has a mass of 4. The number underneath, that refers to now the atomic number. All right. So an alpha is a 4-2. It could also be written as its elemental symbol. Well, what element has an atomic number of 2? Hydrogen has 1, helium, atomic number of 2. So it could also be referred to as a helium 4-2 as an alpha particle. All right, so two different ways to write the same symbol. They cause the most damage, but they are the easiest to stop. A piece of paper is good enough to stop an alpha particle. The next particle is beta. Beta kind of looks like a B with the tail, and that is a 0, -1. Well, what is a 0, -1? This particle has no mass, and it's like the opposite of an atomic number, which is the proton. It's the opposite of a proton, which is an electron. An electron is also known as a 0, -1 now. It does a little less damage, but a little tougher to stop. You need something like aluminum foil to stop a beta particle. Gamma radiation, and I know I have a particle there, but probably here is gamma radiation. Gamma is a 0-0. Well, what's a 0-0? No mass, not anything. We refer to this as energy. Energy, this does the least amount of damage and is the hardest to stop. You need like a lead box or something. Like if you were to go get x-rays taken at the dentist or the doctor, they usually put a lead vest over you to protect those x-rays from going through your body, and instead just your jaw where they want the picture up. All right, some other particles. All right, so if we remember from notes, I don't know, a few weeks ago, a neutron is a proton and electron stuck together. Neutron is a proton and electron stuck together. So maybe we could write it like this. A neutron, what would the number of symbols for a neutron be? Well, it has a mass of 1, but is not a proton, so it's got an atomic number of 0. And we said, so equals, and in science we use an arrow for equals. Proton has a mass of 1, and of course it's a proton, so it's an atomic number of 1, plus an electron, which we already know is a 0, -1. So now we have our math equation here. Up on top, we have 1 equals 1 plus 0. Down below, we also have a math equation. 0 equals 1 plus negative 1. We're going to use this concept right now to do some problems, do some equations of decay. So for example 1, krypton 87 decays by a beta emission. So what that means is krypton 87 breaks apart and something new is formed and a beta shoots out of the nucleus. So let's try to represent that. So krypton 87 and then decays. Arrow. Something is made, something new is there, and a beta shoots off. What's a beta? 0, -1. All right, so I need to know what the atomic number for krypton is. So I go to my periodic table, and krypton is 36. And now I have some equations to solve. I have a mass number equation and an atomic number equation. And I'll just write it off to the side here. I have 87 equals something plus 0. 87 equals something plus 0. Well, of course, that missing answer is 87. Next, I have 36 equals something plus -1. Well, what plus -1 or what minus 1 is 36? That would be 37. So I need to find what element on my periodic table is 37. There's 36. 37 is rubidium, or B. All right, why don't you guys try this next one? Pause the video as needed. Example 2. Curium 240 decays by an alpha emission. All right, so pause the video and see if you can solve for that one. All right, so curium 240 decays something and an alpha. And alpha is a 4, 2. Need to go find curium. Cm right down here, number 96 is its atomic number, so that goes there. All right, so now we need to do our math again. Here we have 240 equals something plus 4. So the missing number there is 236. 236 plus 4 is 240, and 96 equals something plus 2, 94. And look back at our sheet, and element number 94 is plutonium. P-U. All right, so that's radioactive decay. These are a good list, not these two answers down here, but alpha is a 4, 2, beta is a 0, -1, our gamma is a 0, 0, neutron is a 1, 0, proton's a 1, 1, our electron, of course, is just the beta. All right, these particles will be helpful for the assignment that you're going to get, that you're going to start working on now.